but I'm gonna make one of these, but with only math. So I'm just going to, yeah, let's see. So wait, so when I have this open, how come the other thing changes? Oh, because it's showing, yeah, it's showing just the display. So let me get rid of that. So yeah, so I'm making one of those fences. So I have it in front of me so I can see like what I need. And then I'm going to try to use math using sign distance fields or sign distance functions to make this a model of the fence. And as I go along, I'm going to explain to you like the thought process, everything that I'm doing, so that you can do it. You can make one yourself. And then, yeah, that's it. So I've started with this ray marching template, and so I'll just quickly explain some of the things that are in here. This is like a cue to myself. So like whenever I open this template, I already know that I'm going to go to the map function. I'm going to fork it, which I did, and I'm going to brain dump around like the first shape that I'm going to need. But what else can I show you guys? So the main things that are going to be used here is, so there's a trace function, which is the ray marcher loop that's going to go through the world in steps and estimate the distance to the function. And then we have like a normal function that's going to get like the normals for that shape that we make. And then we have an ambient occlusion, which is going to help us calculate and simulate some sort of like ambient occlusion, which is like when you have two things close to each other, there's a little bit of shadow, this almost like ambient shadow. And then we're going to have the camera ray, which is what we need for the ray marcher. And then we have the main loop where we do the ray marcher, we get the normal, and then we do some lighting calculations at the end to make it look nice. So now we're going to go up here, and I have some stuff that I like just commented out. I'm going to get rid of it though. And we have this basic function that's showing a limited repetition, like the more complex version of a limited rep of some boxes. But we can get rid of this now because I'm probably not going to go into that version in this video. I'm just going to do something really basic. So SDF box, I have a SDF function already up there in my code, and I'm going to apply P, whoops, and give it a dimension and close it. So this ray marcher and map function return two values. The first one is the distance to the shape that we were calculating, and the second one is an ID for that shape. And the reason why I want an ID for each shape is that I want to be able to color it differently. So right now that ID returned is 1, but we'll see that as we move forward, we're going to have different IDs and we're going to give them different colors. And that's going to allow us to make a more realistic wood. I just want this rotation to just be like just a constant rotation. So we just have a box rotating in space with some basic lighting applied to it right now. Okay. So to get myself set up, I'm going to leave this as like the global rotation, but I'm going to create a new p value. I'm going to call it pp, and it's going to take in p. It's going to become p. It's basically a clone of p so that I can do things to it without affecting the original p, and p is the position of the ray marcher that's stepping through the world at whatever point it's at when it calls this map. So we have a where it's like you can picture yourself walking through a dark room and putting your hand out as you walk. So wherever your hand is, that's P. And then you take another step, you put your hand out again, or basically you take a step into a room, into a dark room, hoping that you hit something. And for each step, you are at P now. So we're evaluating everything here based on that. So we're going to take our P, make another P, and then we're going to, so we're going to PP, and then we're going to have I want to do a repetition because a fence generally has a bunch of these wooden panels. And so I want to first make the space repeat so that every time we were to draw this, so that every time we have a 0, 0, we draw this box because the box is drawn around the 0, the origin of the world. So we're going to repeat that origin. Um, Actually, the most basic way to do that actually is to take p of x and return fract p of x. Now, that should give us, what did I do? Oh, right. So, dimension mismatch. Oops, I made p a vector 2 instead of a vector 3. All right. So, yeah. So now we have a box that repeats on the x-axis just all over. And of course, we can make it repeat on every axis. And then we have, you can't even see it now, but it's just, yeah, we can do like just 2 dimensions and have boxes like that. And you can make tiles out of that. And that could be pretty cool. So we're going to just do X because we're just looking at a fence right now. And then the next way to do it is we can change, if we want to change the spacing, then we, instead of using fract, because we can use fract and then we can change like, but fract is going to be from 0 to 1, and then we can only subtract something like something less than 1. So that limits us, because if we try to subtract something that's smaller than the size of the box, then definitely we're going to get like some artifacts. So we have to change the box size. Actually, no, we can't even do this unless we do like this, and then, and then we get that, and then we could do this, and then we get that. But that's changing the shape. Okay, so we need something else here. So let's go mod, which is like, you know, the modulus operator, which basically says like how many times does this go into this. So we're going to say how many times does 2 go into ppx, because you know ppx is actually like the positions, all the possible positions along the in the world at the x, like on the x, like in that direction. So now if we divide or get the modulus of that and 2, then it basically goes 1 to 2, and then it repeats from 1 to 2. And so if we divide 1, now it goes -1 to 1. Now fract was going from -0.5 to 0.5, and we couldn't do any better than that. Here we can. So now we can increase the spacing from this to even like that. So we have way more kind of like, or we can go to the basic what fract was, which is this. So that's cool. But if we want to have something that's like a limited repetition instead of constantly like repeating all the time, then we need something different. So let's start with an ID. And the ID is going to be made up of round of p.x. So that gives us an ID. What I mean by that is, when you round something up or round something down to an integer value, like when you're thinking just outside of computer science, just in general, you'll generally be like, okay, round this to the nearest integer. So if it's 0.5 or 0.51, you'd round it up to 1, and if it's point like if it's 1.9 1.49, you would round it down to 1. Okay, quickly checking to see if anyone's messaged me. All right, connecting to chat. Why did it disconnect to chat? All right, so we're connected to chat. Nobody's there. All right, let's continue. So yeah, I'll set the timer again. 10 minutes. So I feel like I'm giving a very deep explanation of this entire thing, but so that's what round does. So around every integer, you're gonna have a point, like -0.499 up to 0.5 around every integer. So then with round, you just take the integer and you get rid of all the other stuff. So like if around this, you can see my mouse. Okay, hold on. So like this, if you look at this cube right here, this would be placed at the origin. So you'd have -0.5 to 0.5 here, but you'd have like, hold on. Like let's say if this end of the screen is like -3 or negative, yeah, then you'd have -2, -1, 1, 2, 3, like that. So then we're just gonna get the IDs by using round. And that's ID that goes here. And then we're going to use that round value to actually create the spacing of the world, so that instead of having all of the everything, like all the coordinates from negative point 0.3 to point 0.3 with all of the decimal points in between, we're going to subtract that by the rounded ID value, which is going to remove all of the integers, so that you're only going to get a bunch of spaces that go from negative point 0.5 to point 0.5 basically, or negative 0.4999 to point 0.5. So all you have to do is take the ppx and minus the ID, and you get the same thing. You can see it's basically the same thing. Things shifted a little bit because of the rounding, but now you can take the IDs and put them in here and get different colors, because down here my um, down here I have a line that actually creates the color, and it takes in the ID to do that. The output of the trace function, the second component here, is the ID. So we are creating colors now. All right, so now you can see how that works. Now we want to make this more, elegant, because right now, the way this works, you're still getting all of the IDs, an infinite number. So what we want to do is we want to limit it so that it only works up to like some amount, like maybe 3 blocks on each side. And then after that, it repeats as if it's just regular space, like with nothing happening. Like basically what these are like zeros that we've kind of cloned by subtracting IDs from the integers. We want to stop subtracting the IDs from the integers after a certain point, so that after that point, there's no more zeros. It just continues on. So like if we stop subtracting after -3 on this side and 3 on this side, then after that, you're just going to get a continuation from 3 or -3 onwards in those directions. So to do that, we can use the clamp function, and we'll go -0.3 to 0.3. So now we're clamping just like I said, and if we rotate this around, you can see that it stops. It stops, like you don't see all of the cubes forever anymore. So that's like a good starting point for everything that we're going to be doing here. You can see how the IDs work, you can see how the repetitions work, and now we can continue on and start making stuff. So we have the IDs, we've got, oh, right. And the other thing is we can change the spacing. But let's do that in a second. First, we're going to make this look more like what we want. I'm going to stop the rotation for a second. I'm going to, let's see. I'm going to start playing with the actual shape. So that's more like looking like a wooden board already, but let's get even thinner and thinner. And then we're going to make this smaller. And now we've got these, maybe like that, or like that. So those are kind of like what a fence would look like in terms of like the actual small like part. But now you see how the spacing is too spaced out. And remember how with mod there was a way that we could space things. So I want to find a way to space things here too. So I'm going to put SP, which is going to be like spacing, right? Right now, the spacing is this. So this is going to be hard to visualize, so I'm just going to kind of rush through it, but at some point as I make these videos, I'm going to have like a diagram that shows you how all of them, like how it all works. And so as I explain it, I'm going to be able to pull up the diagram for you, and you're going to be able to see exactly what's happening. But so for now, we've got the 1, and then we've got we've got SP here, and then on this side, SP. So what we're doing is, for the round, before we get the IDs, we're going to change the space. We're going to transform it so that, like for instance, right now SP is 1, but let's make it 2. So what happens if you do this? So we have the space on the x-axis that goes from, like, say -0.3 to 0.3, but then we divide everything by 2. So now it actually only goes from -1.5 to 1.5. Right? Which means in order to get to the clamp, to where we are clamping, which is -3 to 3, that means that we have to take twice the amount of rooms. Or in other words, what this is doing is it's compressing more into the space. Um, yeah, right? It's compressing more into the space, and then after that, I might have that actually backwards, or is it stretching things out? Or is it stretching things out? No, because if we had no, sorry, it's stretching. Let's see what happens because this is something that like I didn't sleep well last night, and that's yeah. So we're gonna do this, and now when we do it, yeah. So it's stretching things out. My bad. So what we do is we have the original space, we divide it by two, and then we get our IDs there. So but then before we subtract from the original P, we multiply it again so that we I'm gonna have to make a diagram of this and write it down, and then not only will I be able to explain it to you, but I'll remember it better. But it's something like we are stretching the space, but then we're also adjusting the ID so that they still make sense, so that when we subtract it again, we get the spacing we want. So now we have the exact opposite of what I was trying to do. So we're gonna do this. Like we're gonna do zero point 0.5, and that gets us nice, like way closer for like some sort of wooden thing. Wooden, but let's go like this, right? Does that feel like fancy? But also I want to make, I think a fence usually has like 10 of these, which is like that, which means either I have to reduce the width of them or increase the height. That feels more like a fence. But okay, I'm just gonna quickly peek at the fence and count how many there were. Because something makes me feel like it's not that many. Like one, two, three, four, five, six, seven. Yeah, it's like 10. Why does mine feel so much more? Let me see. One, two, three, four, five. One, two, three, four, five, six. And then this is like way, like not the shape that I was supposed to be. I mean, I could always do this, but that feels kind of like I would rather things be symmetrical. And we have things on the sides. I think this is what we're gonna have to do. Yeah. I don't know. We'll see. It might not be enough, but that's like 9 basically. That's okay. So that's our like we're starting to make a fence, and I'm gonna go here to the camera now. This is where I've set up the camera distance, and we're gonna move ourselves back a little bit so that we can see everything more clearly. Okay. So now I think we can start to rotate things around like this, but like so we can see what we're looking at. And now I'm gonna, right, oh yeah, and so now that we have that basic thing, I want to take a second and show you how you can add some more variety. So we already have the ID, which is like, that's gonna be the driver of all the variety that we add here. So some things that we can do are we can rotate these boards a little bit on whatever axis we want. So we're gonna go p dot x xz. No, let's go. I'm gonna have to check the thing soon. Okay, so we're gonna go p. Hold on. So right now this is on the x-axis. So we want to rotate on the x-axis so that some boards are going like that and some are like that. So that means the YZ, and we're gonna do we have a rotation function already, and we're gonna use a hash. So we have a hash function up here that just creates a random hash value from a float and gives us a float back. We're gonna use that. We're gonna put an ID, and we're gonna make just a small amount of that. So this is like that hash is going from negative 0.5 to 0.5, and now it's like negative 0.1 to 0.1. So we're using that to rotate each of these boards separately, and then we get this. And there are some artifacts when that happens. So like you do have to be careful, and that's one reason why I wanted to use the other limited repetition, but we're just gonna go smaller with that and hope for the best, and also make it like more random so that some are moving this way, some are moving that way. I'm really not liking the artifacts. Um, let's make it 0 for now, but just so you can see like that's something you could do. Another thing you can do is you can move like the where the board is, like by moving the space that the board is on, just move it a bit. So like on the Z axis, we can go. So this PP is like, that's the value that we're passing into the sign distance field to create each of the boxes. So if we change how that where that P value is, based on some other thing, then we can actually change how the box, like we can warp the box. So now we're gonna add as the sine function, because that's like a really easy one for making wavy shapes. And in that, we're gonna put the Y value, the original PY value, plus another hash. Well, we can just use this. So we're gonna have that as our hash value, and we're gonna put this in there. And then close that and make it smaller. So now we're gonna add a small amount of that in all of them. Now let's do, we're gonna make this Y like happen faster, like we're gonna scale it so that we get more ripples in it, but not too many more. So like that. And then also we want to scale the hash value, the random value, so that where they start from is different for all of them. So now we get something like this. So tons of artifacts. I know it's hideous. We can reduce that now, but that's just kind of like just to show you what you can do there. And now, so there's a little bit of random. It's not perfect. I know the artifacts we're gonna fix later. Okay, so that's that. And now the next step of this is we're gonna add another box. Once we've added a second box, the process will basically repeat. Let's see if anyone's said anything yet. Connecting to chat. No. Okay, we'll continue after some water. So let's start by making another P. Wow, it's just getting so hot in here. Anyways, another P. And then another SP. Well, this time we're not just gonna use an SP. So we've made the fence, like the basic panels for the fence. And now I want to make something along the tops and the bottoms to kind of like, I don't know what you call it, like just to finalize the fence. I don't know, to support, like as part of like the support and part of the like the natural segmentation of the fence. So we got our original P. So we're now just centered at origin. And we're gonna go pp.x equals abs p. Wow, why is it so hot? Oh my god. Okay, put the fan right on me. And like, what else can I do? Do I have to take my, like, am I supposed to take my pants off? Okay. Dude, sorry, I didn't mean to scare you guys. I had to just take my pants off. It's too hot in here. This whole place. Fucking landlords. Okay, so abs. So if we make if we take ppx and then we do the absolute value, then instead of having like a positive on the one side of 0 and then negative on the other side, we have positive and positive, and then we subtract at some value. Then we have two zeros that are like kind of like over there. So we basically mirrored the space and we can make two of something. So now we can take our, like we could basically take this and put it there, but we're going to make another vector. It's going to be called h, and that's going to be like the thing that we add each time. So we have now a box and we're drawing it. We can get rid of this for now because I'm going to do something else there, I think. And then we can make this like thicker because I want to have like some beams and there should be like square-ish beams. And then the IDs currently are just the IDs from the last thing, so that's gonna look a bit weird. But um, let's make it like this right now. So it's just one. And then we are going to add the H to the T so that you can see. So like if I were to just return the H right now, you're gonna see these two things. Um, so those are our beams. And now I want to add them together. So I've got this cool define function here that defines a T equals Tx. If the original T, like if T was smaller than H, then we're going to use all of T, so the T, X, and the Y, which means the distance and the ID of T will remain T. Otherwise, will the distance of T and the ID of T will now be H. So that allows us to add both the new distance and the ID as well all together into this. So we're going to use add H with no semicolon or anything. It's just all done there in the function. And then we start. So now you can see that we have both of those shapes in there somewhere. But it's hard to see because the color, and also we need to move them outside to the edges, like here. There we go. And then make them, I think they should be larger. Yeah, because it's like, this is supposed to be like fence stuff. So they're out here now. Maybe even further out. Either make them further out or I should move these closer together. Which one? Whoops. What was that? Hold on. Why did changing SP just change everything? Um, okay. So there's that option, and there's the option of making these thinner. Let's bring the rest of this down here so I can see it. Like that. I think that's cool. So now we have our fence with our 9 like segments, or 1, 2, 3, 4, yeah, 9 segments. Okay. I don't like the coloring. Maybe you can change it. No? I don't know. Why is the color so weird? Oh, right. And I'm supposed to use ID, I think. I don't know. Okay. Whatever. That's the ID. So, um, we got these two. And then if we want to have these two also have different IDs, then we just have to take. Did I start another timer? Hold on. So I'm getting distracted. So I'm going to take this and I'm going to go, I'm going to try to find the actual IDs of each of these, or create IDs for these by just saying like, if we're on the one side of 0, the ID should be one thing. And then if we're on the other side, it should be another thing. So we're just going to take ID. We already have that defined, and we're going to go float. And inside the float, we're going to add a Boolean, and that's going to say if p dot x is greater than 0, not less than 0, or if it's not. So basically, the Boolean is it's going to be true or false, but then in float, it's going to be, I think, -1 or 1, or is it 0 or 1? And then that will be the IDs for this. And then we will have 2 different IDs. So you can see that one has changed color slightly. We can ramp that up. Now it's completely 2 different things. So that's cool, right? All right, so now we're going to do the same. Oh, right. Also, we can take advantage of these IDs and we can twist things. So we can say that PPXZ, so that this axis or this plane, we're going to rotate so that we can make, and we're going to rotate based on the original PY. If we do that, we get this. So they're just like all like twisty. That actually looks kind of nice. I was thinking of just making something like some slight twist, but not like crazy twists. But I actually like this. I think I'm gonna keep it. So yeah, they're twisting. maybe just add the ID in so that they twist at different times. So they're both twisting, but not the same, not at the exact same, like in the exact same direction and the exact same amount. Yeah. So now we're gonna add another value, or another function. I do feel like these should be closer together though. There. Yeah, like that. All right. So next, another P. We're gonna do Y this time, and we're gonna do another one of those. Will be like 1 to start with. Oh my god. And then the ID, we already know how to make that, so we're just gonna make that here too. And then we have we're not gonna do anything with the P yet. We're just gonna have like it be flat. And then, oh yeah, so I have this already. So we're gonna take this, make another H value, get rid of this for now. And we're, instead of having these tall beams, they're gonna be beams like this way. So we're gonna move this over to the X channel, and then, well, yeah, let's see what that looks like. Add H. So those are the beams, and we want actually it to be more flat like this, because I want them to be on top of the fence and like on the bottom of the fence. But you can see already how it's kind of like the wood is like weaving around it. That's actually a nice effect too. But in order to make that work, I think you'd have to be specific about having it weave either this way or that way for like a certain point. Like every wooden plate would have to be doing this so that you can have something going through it. Otherwise, it's going to look like it's clearly going just through the wood randomly. So that will be for another time. So we're going to move this. We're just going to just adjust this way. So we'll take this one and we'll go like that. And then we'll go like that. Good. And now we're going to move this up. So we go like there. But that's too... Let me just take a look at the original. No, it's not even like that. My bad. So it actually is like this, but just move it up and make it thicker on the Z. Like that. Let's move around, see what that looks like. And then what? Yeah, it's not as much as that. And like maybe like this. Right. But then these things should be longer. This is going to be a big fence because these should be like here. Yeah. Yeah, they should be like that. Okay. And actually probably even higher than that. But so we have that now. And we can do the same thing with this one where we can warp it or change the angle, and we can get away with that easily because there's no, like, the repetition isn't even happening. It's just a mirroring. So it's easier. What axis are we doing that on? I say on the PXY we should do at least some sort of rotation, because that will be like, it'll stand out clearly if we go it's just a rotation. So we'll just do this. Yeah, that's too much. Okay. Oh, the other thing is because one of the IDs is 0, it doesn't move. So there. And now we take that though, and we're gonna put that in a hash. And then we're gonna reduce the size of it. So there's some amount of movement, just a little bit. Everything is a little bit off kilter. I like that. And I think I want to do the same thing over here. Move things just a little bit off kilter if I can. But let's do that before this. And that's even too much. Like, just a tiny bit. Okay, so now back to here. Back to the beams. We're also going to go like maybe just a little bit like on this one. this axis. So that's the XZ axis. Or should we do the X? Let's do the YZ axis. So now they're like moving like a little bit like that randomly on each side. So that's what we got for our fence now. Things are kind of weird. Okay, nice. Maybe a bit too weird. I don't know. I might not want to do it that way, but like for now. All right, so next, now we want to make some interesting stuff on the top. I think this is too much on this side. No, wait, sorry. Why does it feel like one is way shorter? No, it's an illusion. Okay, whatever. Oh, right. I know what I'm gonna do. I'm going to move these beams, the side beams, up because I want to have some like decorative stuff on the top. So we're gonna take the P of this and just shift it up a bit like that. And then I want to move the camera back so I can see more. There. So now that's what our fence looks like. Now, let's go. You know, it'd be also cool if like I had these things like the side ones like go into a point at the end, but I already have a plan for what I'm going to do there. So we can basically copy and paste this. And then we're going to have, it's going to be the X though, and same distance, and then same ID, but maybe we'll add like something, I don't know. And then, no, that should be X based. ID based on X, and then we can keep the, let's get rid of these for a second. So we're gonna make two more boxes like that, but we're gonna make really, I want some small, square, thin like plates that are gonna go on top of the beams. I wonder if I can do that while the beams have different heights, the way that they seem to. But I don't think the beams have different heights. I think this is making it look like they do, which is actually a cool kind of effect. So one because they're square, and then so those are the things. Maybe wider. 1.5 or 0.15, sorry, 0.15 more maybe. 2, I want to see them. Come on. 2. Okay, there they are. Now we're going to move them up. So let's go to the Y, and we're going to subtract some amount, like 1. Move them up. Okay, more. 2. Okay, a little bit less. All right, 1.8, 1.9. All right, now we got to move them out. Like this. All right, like that. There we go. So we got something on the top. Let's take a break. Anyone commenting? One viewer. All right. Well, okay. Let's continue another 10 minutes on the timer. Oh, it's 12:43. Let me see. What do I need to do? Do I have more time here? I wonder if I think I have time for one more 10-minute round, and then I might have to go to give myself time to do everything else. Yeah, all right. So right now it looks like this, and that's kind of cool. Although I make this even smaller, like maybe like that. I don't know. Okay. And you can also give this like give these a little bit of a rotation on this axis so that they're kind of feels like they're just slightly more randomly placed. And yeah, all right. So now I want to do something. Oh, another thing we can do is we can add like a little thing on top. We can just add not a square, but like we can just add a sphere on top of everything. Like this. P. And some small sphere thing. You can't even see it now, but whoops, um, a sphere, and then increase the height so that it's like 1. There we go. So now we got like a sphere on top. And why is the difference so great between that? Huge difference there. Okay, cool. So that's going to be our little decoration on the poles. And then now we're going to move on to another one of, well, we'll make it ourselves again. So P, and then we're going to have another SP. And it's probably going to be like this. If I'm not going to lie. It's going to be a lot of small kind of pieces. And so we got SP, and we're going to have the ID. Whoops, we don't need float. We're going to ID. It's going to be round PP, and then it's going to be on the x-axis, divide by this, and then the new P, which we're only adjusting the x, it's going to be SP times clamp of the ID, and it's probably going to be something like -8 to 8, because we're going to make a lot of these little things that are going to go along the top, like little like teeth, and then we're going to have like other ones that are going horizontally, so it's going to be like a lattice on the top of the fence, and it's going to look pretty. And then we're going to change like the height of them so that it kind of has like an interesting flow. And then we're almost, and yeah, and then we'll almost be done after that. So we have this P, no errors. Now we're gonna make the SDF. Whoops. Can I just copy paste some stuff like that? Yeah. All right. So now we have that P. We're gonna make an H, and the ID is the ID, and we have to change this to. All right, and also we're gonna move everything up because it has to be at the top of everything. So those are them right there hanging out, but they're like the wrong orientation. So I'll see if I can just adjust it. And then that should be the flat part, but this should be taller. Oh, okay, so like that. And then we might need way more because, but let's make yeah, so that's the sizing I want, like the width. Oh my, these bugs are out of control. The spacing needs to be larger. Okay, so yeah, maybe we got it, because that spacing is kind of okay. Yeah, I don't think the spacing is a problem. I think, well, let's see. How many of these? Because that's not as many as I expected to fit on there. So I think it's a mix of the spacing and then the width. I'm gonna reduce the width, and then we're gonna reduce the spacing. Because I want to have like almost like squares in between all of them. That looks better already. So now we're gonna change that part of it. So it's not just gonna be it's not just gonna be Y. We're also going to adjust it based on the original X. Like you see how that's doing it, but that's because we're using sine. So it's going like from 0 up to 1. But we want to use cos so that it's like, so that 0 is so 0 is where we have 1, and cos 0 is 1. And so then it's going to go like this. That's that. So now we want to bring it, I now want it to be like not just an arc, but I want it to be an arc with like a little wave going back the other way. So I need to increase the size of this by something. I don't know how much. like that, maybe more. And also now I'm seeing how big of like an amplitude we have. We have to reduce that. So let's do this. Okay, so now we can start to see things working. What if I just go pi? Yeah, there we go, pi. That ends up being what we want. And then maybe like that. I'm gonna pause this because it's kind of hard to see what we're doing. So we have that. I think I want, wow. Yeah, I think the amplitude is too small now. And then I think I want to have more happening in here. Is that too much? Yeah, no, that's too much. Yeah, I was right before. Um, the only other thing I can think of is I feel like we still, like I wish more could fit in terms of spacing. And then we have to increase the height more, or but not that much. Like there. I want the where it ends up to be exactly where that wooden thing is. That's where I want this to end. So it's a bit higher than that right now. And I'm gonna put something on top, so it should be even lower. So like there. All right. But also we're starting to see some of them come through the bottom, which means it's already too tall. So we're gonna reduce this a lot, I guess, and then bring it up more. Okay, that should be good. So now, and we've added it, and oh yeah, so now for these ones, we can also do a little bit of like a movement, and I'm gonna do that on the Z axis. So we get, yeah, so now it just kind of looks like things are like not completely properly placed. Kind of an interesting look. Add some realism in my opinion. I think I want to go like that, and then that's a little bit there. Okay, so now I want to move on to the next level, and I want to add more of these. So instead of, yeah, so we're going to keep the Y value, but there is going to be another repetition, but it's going to be on the Y axis now. And we're going to do that. And it's just going to be 3 of them, I think. No, sorry, yeah, 3. So it's going to do -1, 0, and then 1. And this, I don't think we're going to move these at all. And so now we want to have something wide, like 1, I don't know, 1, and then that. So if we add that, ooh, okay, too high, too short, okay. And now we're going to make this larger. Right, so that, but then we want these things. I should just zoom in so that you can see, because now it's like we're talking about something smaller. I want you guys to be able to see what I'm talking about. Ah, that's annoying. Let's just move the whole world up. Um, um, the other way. All right, so can you see that more clearly? So these things, I want them to be like along this kind of shape or curve. So that's the time. I might have to stop. But okay, let's go just to 1, exactly 1 p.m. Ah, then I won't be able to shave. Hmm. Well, while I'm deciding what I'm gonna do, let's just keep going. There, we got that. And now I'm kind of thinking like, I don't want that much wavy. I don't want that much wavy on any of them. I'm starting to see it. Okay, so now we have this, and I want those to be out, like, I want, oh, these are also kind of thick, like on the Z axis. So we should change that on both of them. They should be thinner. Um, and okay, I'm gonna give this a name. X brace fence incomplete. Okay, save. They always do that. I can't save until I sign in because we don't want people using AI and stealing all of Shader Toy and then using it to make money and not paying us a cent. So that's why we have to sign in again. That's okay. Like that's fair, right? So now we're gonna go Z and move these on top. So now these things are like above, but more above, like there. Whoops, sorry, I can't see that. So yeah, so they're like clearly in front, right? So now it's kind of like decorative. And then the last thing I do is add another one on top, and it's going, okay, so there's two more things. I want to have one like flat piece here, and I want to have a flat piece here, but this flat piece won't be like wavy. Um, but this one will. So we'll just do this and we'll do that, keep that there. We're not going to have any IDs. We're not going to have any repeating. We're just going to have like a box that's going to be that length, but like way more here. And we're going to add it. What? Okay, I think it just showed up, but we need to move it up higher and up higher. Okay, 2, we're doing 2. No, 2. That's too big. That's kind of cool, but yeah, it's like 1.9 there. Okay, so there's our top. Oh, I see the thing sticking through. That might be a look that some people would want, but otherwise you do this. And I think I want to have it more coming out like that, because after all, it is supposed to be like a top thing. And then we have another one where we're going to keep the same dimensions, but we're going to get rid of the movement and we're going to move it down more and more. And now the thing is we got to rotate it the same way we rotated that top piece. Now I have to go digging for it, but you get the idea. Was it this one? Oh my God, I don't even know where to look for this. What if I just do this and see what happens? No, it's one where it was X, no, it was on the Y. I think it's this. What happens if I do that? Yeah, it's this one. Okay, so I'm gonna take this. I'm gonna take the rotations so that I can just keep both of them. And then the ID will be the same, but it'll be either 1 or 0. And there's no ID here. So I'm just gonna make an ID. And I'll just start with 0 and see if that's the one. Yes, it's the one. Okay, so we're gonna put that on top like that. And now, whoops. So now we've got something like that. Okay, so all we have to do, I mean, we're pretty much done. Like, I think I literally just got it in time. Um, Although I don't know how, okay, let's just make sure no one's talking to me right now. But, because I didn't set the timer again. Just quick check. I don't see any communications connecting to chat. No, okay. So, we're gonna go to the camera and we're gonna move us back out. And then we're gonna move back out from the thing that we did here so that we are, and then we're gonna move back out more. Is that what we need to do? Is that what's happening here? Okay. All right, so there's our fence. Now, if you want to make it look more realistic, there's a few things that we can do. We can take it and we can add noise. So I have a noise function, a Perlin noise function that IQ wrote in his most recent video. And I have that here. And then I'm just going to literally apply that to our fence to make some bumpy stuff. So first, let's just get the noise. I don't know. Oh yeah, I have a global called G noise. So I'm just going to write to that with the FBM of the original P so that it's rotating along with everything else. And that actually changes the color because the G noise is already going to the color. And then we're going to make that apply to the actual texture, like the actual geometry of our sine distance function. So G noise with like very small amount applied, so you can see there's some roughness, and then also we're gonna reduce, or we're gonna increase the scale of P going in, which also changes the noise. We're gonna get rid of that noise though, because it's like not that important right now. Now we're gonna go and finish off. I mean, we're gonna get rid of the color. I like that color. That's the normal color, and we're gonna add some wooden color instead. So there's wood, and then we're gonna add some lighting. I think I'm gonna have to leave the lighting, you guys. It's already 1. That's as late as I was planning to do it. So I'm leaving the lighting this time. Next time I do this, I hope to have some lighting added. But there's how you can make a fence. So let's see. I think I'm gonna just end off by showing the fence within me on top. So like, what if I just do this and then put, whoops, and then put video capture on top, and then I can go full screen, and then we'll end with me my conclusions. How does that seem? Like, okay, so that is how you make a fence. I haven't looked at the camera in like 30 minutes because I've just been working, but that's how you can make like a cool looking like haunted fence um like model with only math and shader toy. And so what I could have done, what I want to do next time then is use a special type of repetition so that these kind of like artifacts don't happen. And I'll explain in that time when I do it why those artifacts do happen, and we'll get rid of them. So now what I'm going to do is I'm just going to post this on Shader Toy. I'm going to publish it, public and API, and I'm going to end this video. So thank you and the stream also. And so thank you all for watching, and I hope you enjoyed. Let's see. Yeah. Hope you enjoyed, and I'll see you in the next one.